All right, welcome back. We are drawing the segment routing field day to a close, and it wouldn't be complete without having a tech field day delegate roundtable. Now, all of you watching at home, hopefully this is you're cheering because this is your favorite part of tech field day, where we take all the things that we've been learning about all day long, in this case segment routing, and we kind of dissect it, we discuss it, we bring up questions that we would like to have answered. That's what delegates do, is we ask lots of questions and we wait for answers. So we have a few topics that we're going to discuss here. I think it should be a really great time. Still looking for any questions you guys out in Twitterverse might have, so definitely share those if you have them. What I am going to do is I'm going to have the delegates all introduce themselves so that you know who is talking, and then we'll launch right into the discussion points. So Terry, take it away.
I'm Terry Slattery. I'm with NetCraftsman, and we do consulting. That's it.
I'm Nick Braulio, all-around networking dude.
Jason Edelman, network automation dude. I write at edelman.com, and on Twitter, I am jedelman8.
Carl Niger, work for Lumos Consulting.
John Langmuck, network architect for a healthcare company.
Russ White, network architect, LinkedIn, rule11.us.
I'm Larry Smith.
All right, so we just spent a whole day talking to Cisco as well as some of the implementers of segment routing, and I think there was some very interesting discussion about use cases, some very novel ways to use this protocol to solve some real networking problems. Some of the things that the delegates brought up from discussion points that I kind of want to toss out as thoughts for the people around the table is one of the discussions we were having with Matt Hato earlier on Twitter was about viability of this protocol from an enterprise versus service provider versus hyperscale market, because let's face it, I mean, I think I had a discussion with somebody at lunch. When you've got 9 flows in your environment that are a herd of elephants, this makes sense, but in an enterprise, maybe the use case is a little less apparent. So I want to toss this out, and I'm going to start with John Langmack and ask you, what do you think about enterprise versus service provider versus hyperscale when it comes to segment routing? Do you think that this flows up and down the ladder? Do you see one being a better choice than the others?
Segment routing in each of those cases?
Yeah.
Yeah, so I mean, I think part of the thing with segment routing is, in the enterprise space, particularly, I think we look for protocols that are well understood, mostly because the biggest problem there is troubleshooting. So it's an operations problem, right? So when I look at something like segment routing compared to MPLS, there's a trade-off for me between the complexity of MPLS, the things that come along with it, compared to it's been around for like a long time and it's pretty well understood and it's pretty stable. It's used everywhere. So segment routing, definitely has some pieces of it that are appealing. Pulling it down closer to the edge makes a lot of sense to me, but there are also some concerns. I mean, I get the application angle of this, right? Like letting the app drive network pathing, but I can just see the instant that comes up the security guys saying, well, wait a minute, if the app is deciding where it wants to go on the network, how do we guarantee that our security controls are in place, right? Because a lot of that is driven based on default routing or something. So there are pieces of it that seem pretty appealing. But again, I think until the code's out there for a couple of years and some of the stuff gets baked out from an enterprise perspective, MPLS, it's a trade-off there, I guess, right? Whichever one, operations or the technology.
Cool. Anyone else? Thoughts?
In certain instances, it'll suffer from the same critiques that early controller-based SDN fell under, right? You've got this central device that has topology data, in some cases, right, if you're using a PC. And how, you have to think about that as somewhat of a decoupled control plane. So you have to armor it as if it's, if it's a host or something, you have to armor it as if it's a network device. But realistically, if you add, the pathing in such a way to sort of address what you said about having the, knowing the paths are going through the security controls that they need to be going through. I mean, you can build your physical architecture to sort of address some of those issues so that there's just no other way to do it, no other path to take.
Yeah, the one thing around the security too is not to think, developer or application is going to have direct access. That it's still up to, we'll say, us to develop that arbiter that'll sit in the middle and take in requests, be able to implement them. If it's a static tunnel or if it's reservations and things like that. So it's just be able to decouple the overall, let's say, security requirements, app requirements into a solution that may be off the shelf or custom that would then interface directly with the network versus developer to the network.
But a hard part of that, right, is like all of these things that come up, it doesn't matter if it's a VLAN or VRF or something, right? It's our job on the network side to prove that that's a valid security construct, right? So it's more about proving the app can't push out a label stack that could make things go a different path, right? So you need those means to validate that stuff to prove that it's a valid.
And that's where the whole that's where the whole idea of a path computation engine or some sort of traffic engineering middleware piece comes in, because then you can put a policy on that says, sorry, you can't bypass any of the security stuff. That has to be a component of the path that's created, and the application talks to that, and then that talks to the network.
It's an artifact.
But I think I agree with you that that's going to be a few years before all of that gets baked together and there are enough use cases. The other thing I found was just the documentation for this whole technology was severely lacking. What we've covered here today is a really good basis for somebody that needs to understand what segment routing is, because it covers a lot of the stuff that I found was missing in documentation.
So do you mean RFCs or do you mean documentation, like vendor documentation?
Something smaller than reading the RFCs.
Okay.
What was your definition of an RFC? If it's readable by the average human, then it's not an RFC
There's
yet?
not an RFC yet. Yeah, you got to keep working on it until it's not understandable for the average engineer.
Right.
Yeah, that's pretty much the way it works. Yeah.
So from the enterprise perspective, I think that if the larger enterprises are looking at things like orchestration or SDN for their data centers or whatever, then this is a viable alternative, right? But if they're not thinking about things in that respect and they haven't visited like MPLS for their core, then this is sort of, it's too much, right? It's very likely going to be too much, not only because it's probably more complicated than they actually need, but also because it'll require a shift in thinking to what you said, where you're moving that policy to a central arbitrator rather than building the policy on every physical device.
I think the mindset is more important than the actual complexity. I mean, hard problems require complex solutions. It's just the reality of life. I think we often get ourselves into a tangle because we try to solve a set of hard problems with all sorts of little hacks. It's the car. Our networks are the cars running down the road with duct tape over half the windows because we refuse to take it to the shop and just get them fixed already. Enough, but the duct tape is easier for today. Yeah, okay, well, so I think if an enterprise is in a position to have the real requirements, and frankly, enterprises and transport providers are the ones who are going to have these types of problems. It's not going to be hyperscalers, right? Hyperscalers are going to have simpler problems than this by and
And I don't even think it's even like mid-sized enterprises. I mean, look at the demos that we saw today, especially the spray. I mean, that's totally content delivery, right?
That's totally
applicable at all to
right.
Bob's whatever, Acme Co. I don't know. Yeah.
Although I have this whole thing about the danger of segmenting the enterprise and the service provider markets. There are problems and there are solutions. That's all there is to it.
I still think a lot of it still comes down to controls.
It does.
For me, I mean, I assume that's the biggest is building in that, like you mentioned, a central location. If I can tie into an API and add a central location that is dictated, for lack of better words, right? But I have controls around who or what, or based on my authentication or whatever is the amount of authority I have over my network paths.
Right.
I think that's the biggest hurdle I think that I can see personally is
And it
getting
feels
over.
complex.
Yeah, it does. And I know it's not that complex, but I think just personally, And I think that's what a lot of people are going to get stumbled up on, I think, is I can see the benefits, but how can I control it?
Actually, I think that leads into another question that someone brought up around visibility. So think about this. So as engineers, we don't like clouds because clouds are things that we don't know anything about. So when random things start happening and we need to troubleshoot it, we've got to start peeling all the layers off. How does this solution help or hinder that? And Carl brought up some interesting thoughts around this, and I want to let you start that and then throw it out for everybody else.
Yeah, I'm just thinking, I live in not large enterprise world, right? Regular size enterprise world, I guess I'll say. So I see that most of what we talked about today was content provider, service provider, hyperscale, whatever. I see a lot of mid, I guess, size enterprises going towards stuff like ACI or even EVPN, and ETS, and all of these other things, right? Or I see that the SDNification of all these things is trying to bring, maybe not always bringing, but trying to bring a lot more visibility, accountability, I guess, to the network. And we didn't see any of that with this. That doesn't mean that it's not there, but like if I'm going to be a mid-sized enterprise and put this in my data center, I'm going to want to be able to see stuff, right? If you look at any of the SDN plays for these kind of enterprises, that's like a big tenet, central tenet of this is like, hey, you can actually see what's going on in your network now. We didn't see that today. I mean, standardized labels across the whole environment, I think that's huge. And from a troubleshooting perspective, if you're going to be in this world, I think that's really, really great. But just from day-to-day ops, I don't know that we.
Yeah, I think in general, if it's segment routing, a lot is changing right now in the industry, and features like this can be really valuable. But in terms of having better ways to test before we deploy or require, so it was great. Sumit was talking about, for that 15 minutes that he was up there talking about, testing strategy and exposing some of, the ways Cisco tests when they're developing code internally to their SEs and to their high-end customers. I would love to see things like that make it down to, the little folks like us, right? Yep. That way we can build out some of these, pipelines where, hey, add a new, if it's a VRF for security, things like that, to be able to have these for compliance to hand back internally to say, hey, these are the tests we ran for compliance X, Y, and Z, to know how it's going to be in production. And again, if that starts with VM tests and things like that, I think it's a great step in the right direction. But in general, I think we need better test harnesses to be able to more rapidly deploy features if they really make sense, versus take the 6 months or 12 months. If you can just run a boatload of unit tests and application tests that we can help define, right, or reuse, I think that would really streamline deploying any technology, including SR. So,
and that definitely is I see that as huge. I mean, continuous integration from a networking perspective, right?
Right.
Obviously, you know very much about it, but it does, being able to have something like they were talking about does give a better sense, I think, to some of these companies that they don't know where to start. They don't have a model to follow. They don't know if they're testing their continuous integration correctly.
It doesn't exist today.
It
right?
doesn't exist, right.
Our tests right now are, ping and trace, our ping VRF from this VRF to that VRF, and just make sure a ping gets through. But if we can just have 1,000 tests to rerun pre and post change, if you're adding a new tenant or adding a new site or a new POP or whatever, it would be, again, I get it, it would just be exciting.
Oh yeah, absolutely. Because you've got a repeatable process at that point.
Yeah.
And you know what to expect. And then you add some of the analytics and stuff like they were talking about.
Even more, right.
It gets very, very interesting because now you've got predictability at a certain extent, I think.
Yeah.
Frankly, a lot of the smaller folks probably don't even do any of that because none of it's built, like you said. And if it just became easy to do and it's just another thing you add into the process, I think that would be.
Yeah, that's why I think Russell's right. We have complex, solutions for complex problems, but we still need to make those complex solutions easy to consume.
Yes.
Yep, we do.
That's the key.
That's exactly right.
Yeah.
Got it. Awesome.
So what's interesting in this is that it seems like, given that from the SR path in the header kind of where the packet's going to go, you actually could gain a lot more analytics than what we have today, right? But on the downside is, now we're talking about an application interface, an API that some application is going to be able to touch and create those SR paths. So all of a sudden, all the stuff that I thought I knew
Changed.
has suddenly changed because now it's all dynamic. So yeah, I can trace things more easily, but talk about repeatability. Can I actually repeat that microservice going out there and touching these 3 microservices, touching things in a certain way and creating this path that no one expected, and then when it goes away, and I can't figure out what happened, but nothing worked for 5 minutes, right? How do I actually figure all that into it? That's a problem space. Tracing and logging and things like that, and the levels of information to deal with are going to be a lot different order of magnitude.
Well, maybe a good counter to that is that we're looking at this problem from a troubleshooting perspective through the lens of all the tools that we've already had. And if my toolbox contains a slot screwdriver and a saw, then I don't know how to drive nails until I have a tool that will allow me to do that.
Right.
And so when we start looking at maybe an application can instantiate flows and SR headers into the network without our intervention, we create a method so that when that process happens, that is logged somewhere else, and we have access to that data to say, oh, well, the reason everything broke 17 minutes ago is because 17 minutes and 10 seconds ago, your application did something it wasn't supposed to.
I think, isn't this where we go back to PCE, though? Because that's like the only way we're going to have this.
Well, or
single-
Kafka. Go back to Comcast
Yes,
and
and that's what I was gonna
Kafka
say.
Anywhere
and
there's-
wrapping things in JSON. Right. I mean, that's really important stuff. And then figuring out how to actually run data analytics and figure out what is going on my network and what just happened.
So
And
that brings up a really good point, because a lot of people don't even have that.
Right.
But the ones that do, they rely on very simple things: syslog, SNMP traps, SNMP, baseline data. Syslog being the biggest one, right? And so when we think about this application is going to touch the network and it's going to do something, right? We sort of already have that happening. If you really distill it down, like when ISIS runs and it notices an interface down, that's a piece of software changing the network. And we see that because it generates a log that we see in our syslog file. So if we start asking for things like, I want to know when a new path is generated or changed or torn down, and I want to see that in a syslog or whatever, or a trap, or choose your standard notification mechanism, then it just becomes another thing that's running on the network hardware that also happens to maybe have a PC out here.
But you want to be able to use those same analytics to reverse what just changed.
Well, and that ties back into complex problems have to be easy. If I have to have all this extra goo over here that I never had before, the barrier of entry is substantially higher, right? If I can say, I'm going to point this at syslog, and when this path happens, I see it, that's low barrier of entry because I already have that stuff, and I already know how to look at it.
But remember, how you make a complex problem appear easy is through abstraction.
Right.
And abstraction then puts the cloud back on top of what you're working on. This is like, there's a trade-off, there's a balance here someplace, and there's like a vicious circle you can get into. So we have to be conscious of that and try to make sure we understand.
I think that's the biggest thing, is not understanding it.
Yes, not understanding.
Right. Well, that's what creates the cloud, right?
Right.
The cloud is just something you can't see through.
Right, which is intentional, right? I can't see through my brake system. I just press the stinking pedal and it
Hope you stop.
hope it stops, right?
You know,
It's an abstraction,
Usually does.
right, of an entire complex system that sits in my car,
Yep.
which is great. But if it doesn't work, then how do I fix it? I don't. I take it to a mechanic and they fix it, right? But we're the mechanics, right?
Yeah.
That's true.
And that's where we need, in today's world, in these automobiles, they have complex tools now to take a look at that stuff and figure out what's really happening, particularly the newer drive-by-wire cars. So we need the same sort of tools. So we need tools to help us design. We need to have tools that help us basically do NetOps, the network equivalent of DevOps. So we get the continuous integration. So design, deployment, monitoring, testing. Yeah, being able to stand up a whole virtual instance of our network and be able to run tests against it and then have the promise theory type engines go, did you achieve your objectives? Did the right route show up on this remote site? If you run a test ping through, did it hit all the right nodes and come back, following the correct path that you had said, including going through the security devices like John mentioned earlier?
I think that would be interesting to at least see a demo of some sort of tool. Theory, even if it's theory, right?
And then
this is
what
what in a log, this is what an alert looks like.
Right. And then
now
what
I
we
can
have to
start-
do is teach people
Right.
how to use that instead of the history of teaching people how to go use the CLI to configure a box.
Right.
So, Terry, you are the grand old man of network monitoring.
Wait. Yvonne has that title. I'm sorry. I can't take that one.
We can just call you the grand old man then.
So how do you
Leave the rest
feel about
off.
the use of telemetry?
Oh, I think it's great.
And how do you think telemetry would transform some of the things that you're talking about? So to use your car example, we have old cars, and the way we fix them is with a giant hammer. In the newer cars that are all drive-by-wire, we have these specialized systems that we plug in to pull data dumps. But look at Tesla. Tesla's probably the most advanced troubleshooting out there, and they don't wait to figure out when a problem happens. They proactively monitor all their cars at once. So what they do is they call you one day and go, hey, your left front tire is low, and by the way, the undercarriage is about to fall out of your car. You might want to go take it to a mechanic. And that's that proactive type of thing, so that we see the flow instantiation happening all over the network, and we can see the problems before they occur so we can go fix them. How do you guys think that that's going to play into things? Because really, based on some of the things we've been hearing for the last 6 months, I think telemetry has a really important use case, especially for complicated protocols.
Well, I mean, it kind of plays into the whole, I mean, I know that's where you're going, but being able to troubleshoot what's going on. And in my head, anyway, I can see possibilities as each thing traverses through each, using the example like he used of video transcoding and stuff like that, as it propagates, because it can be dynamic, right? I mean, like the example he gave, it could change at any given time based on the analytics I get. But I still have to have some way to know that this packet, this video or whatever, has to be able to say it traversed through these different ways, because I need to be able to determine what the experience is on the other end. Does that make sense? So where I'm going with that is some way to say, I'm going to add a header or a tag or whatever as I go through these layers. And I'm going to drop it into, say, another analytics or the same analytics so I can see what it took, but maybe strip it off.
You look
Is a
like you have
possibility.
thoughts.
My thing about telemetry, or my concern about telemetry in the industry is I'm going to be a little bit, perhaps, harsh, or whatever the case might be, is I don't necessarily see the vendors pushing this drive, and I actually don't see the IETF doing very much, or the standards bodies doing very much in this space. I mean, not real. There are things going on, but, and there are always things going on, but, is it to the depth it needs to be to get to where Terry wants it to be? And I don't necessarily see that. So it makes me wonder, where does this come from in the industry? I know one possible answer is the hyperscalers like LinkedIn and Google and stuff like that. But a lot of the hyperscalers are more concerned about holding things close to their chest for whatever reason than being open and honest about what they're doing and helping the community. So it kind of makes me wonder, I look around the community and I wonder, okay, I've got Cisco sitting in the back of the room. They're great guys. They do what they do, right? No, seriously, it's fine. And we have Juniper, and we have all these other vendors out there playing around in this space, and they're doing lots of cool stuff. I don't necessarily see the leapfrogging happening in that space, though. It certainly doesn't seem to be happening in the standards bodies. So where is this going to come from? I mean, I know we need it. We all know we need it. But where does it come from? I don't necessarily see the answer.
My answer to that, Russ, is that I think it's going to happen incrementally. And I think you can start with some very simple things like, did the appropriate route show up at the end system where you needed that route to appear? Okay, do you have the right headers, SR headers? Okay, or were they programmed correctly? Was it, and you can get that out of the PCE. Okay? It can log, okay, I did this header for this flow.
So you're arguing for incremental improvements of PCEs. I would also...
And the entire system, as much as you can get to, things that you can get to easily, let's go do them and get that instrumentation now about changes in the routing tables and things like that. And then that can start flowing into the engine. We'll get more experience and we'll find out what works, what scales, what doesn't, and then we can apply that to the secondary problems that occur later.
But are we doomed forever to be cycling ourselves, trying to get things done in this area, if we don't somehow as an industry adopt a common set of, or not a standard, but 80% of things are covered by a common set of objects? So that we can actually build tools that last more than 2 weeks? I mean, I don't know. I'm asking the question. How does that work?
Well, if you don't have the standardization, for lack of a better description, the common set of primitives to work from, then you're doomed to splinter, right? And you'll never have consistency across toolkits and tool sets, which is bad. Right.
We end up with the open source forking problem.
Right, that's exactly what I was thinking of.
Right.
But, in contrast, pushing things through standards bodies takes forever. It takes a long time.
I know.
Right? You know better than probably all of us.
I know.
So, maybe if those things started happening in parallel and there's a fire underneath it, which, I don't know, somebody can light and then fan, maybe it'll happen faster, but I think that, like you said, we're doomed to have...
My answer is it's got to come from us anyway, right? It's got to come from us. People sitting in this room, the people watching this, it's got to come from us, right? Because vendors aren't going to do it unless we tell them to do it. Standards bodies, like you said, take forever to do things, but a lot of that's because they don't have any real input, a lot of times, from real operators. So there's no fires being lit.
Well, what I've always been told is that the vendors want to know what we want, and they want to know that we will pay money for it, right? Because that's what it all.
It follows the money.
There you go, Terry.
Right. And so we're buying this gear from vendor XYZ. We tell them, we start writing these things into RFPs as first desirable, then highly desirable, and then required, and then they're a thing.
Right. Yep.
But it's a multi-year, probably decade-long process.
It probably is. Yes.
It's the thing I look at it being and trying to be, I guess, a little bit positive. If the vendors are streaming data from pushing data off their box in some proprietary data model, that's still a step in the right direction. And if it was standard, that would be
You can write couplers that
or common. But if that means us, writing mini drivers to translate into custom data, hey, you know what, so be it. So if we make progress, pushing data off the box and better APIs, that can then make API calls, make a config change. Then somewhere in between there, we have more intelligence to act based on some of these things that we're seeing from streaming data. But I think a lot of times when we talk about it, we talk about the conceptual of what I call the Holy Grail on telemetry plus config management on closed loop system. Yeah, sounds great, but we really want an open closed loop system, right? That way, it's not maybe coming from from a single place, but it's probably a ways out unless we just stay here for a few months and code away. Yeah.
Are there hotel rooms? Are there hotel rooms available in this hotel for a month? We can all just sit down and knock it out.
There we go.
I think getting the data off the devices is definitely a step in the right direction, but I think the other problem is figuring out what are the key metrics to be looking at in this pile of data, right? And I think that's harder to do without the operational experience with something like this.
True.
But I think one of the things that is easy to struggle with is data overload, right? You get in a situation where there's an outage and it's very easy to look at metrics and see spikes and graphs and say this is a problem when it's really not the problem. So it's about identifying metrics based on the problem, I guess, but without the operational experience of running something like segment routing, you don't know what you should be looking at.
No, that's a good point. So
That's why I was saying.
Yeah, no, go ahead.
I was going to say that's another where I was going with a good example, so we at least could visualize in our head, this is what something bad looks like. This is what something good looks like. You know what I mean?
I think another kind of piece to that too is if we can get the information out and we can codify it as good or bad.
Yeah.
That's one thing, right? But then we also have 70 different things from vendor XYZ or multiple vendors, and those things look good or bad differently. And so we're talking about kind of straying from segment routing, right? that would be great if we could say good or bad for segment routing. That's cool, and then we can get some information. But then the bigger problem is, holy hell! Now we have segment routing, and we have regular MPLS, and we have EVPN, and we have blah blah blah, and they all look different. That's the bigger problem.
Well, and the problem too is that all of these teams that are involved in the problem, right? You've got the vert guys, the compute guys, and everything. They all have their own tools for checking out what they think are valid health metrics, right? So when it's a problem, is it a network problem? Is it a compute problem? So how do you correlate those metrics together, right? I think that's the bigger struggle.
Oh, I get it.
And that's one of the things
He
that
went there.
when we did NetMRI, one of the key points that I used to make with people is you go collect data from the network, and you can get into data overload. How do you take that raw data and convert it into information, which is something you can use and act on? And that's where the correlation and stuff like that you were talking about, John.
Thankfully, we've solved that problem through big data. Big
think so.
data and analytics fixes all of our problems, or so I have been indoctrinated to believe. All right, I'm gonna move our topic on just a little bit because I have one or two more things I want to discuss here. So we saw a lot of the way that segment routing is kind of architected and all the things that it does, but Terry brought up a really interesting point. Where's the QoS fit into this? I mean, I've been dealing with fabrics and tunnels and a whole bunch of stuff here recently, and boy, how many times did you and I have to sit through UC classes where it was, you must use QoS, you must have network services installed on this, or the world's going to end. And boy, when you try to attach it to this, things just start getting really weird and funky. I mean, where do we go from there? I want to ask you guys, I mean, what are your thoughts about network services? Does segment routing fix that problem?
More
Does it
bandwidth.
create a problem?
Bandwidth, man.
Bandwidth.
Right, Terry?
Yes, the answer is always throw more bandwidth at it. But as Yvonne Pepelniak posted today, for those rare cases where you can't throw more bandwidth at it, you have strict limitations, and you have policies that have to be implemented. Now you're stuck. I basically tied your hands behind your back. Where do we go from there? So, discuss, gentlemen.
Yeah, for me, I think Terra's the authority. He's written a lot of articles about the space, but I don't think there's any way to prevent bursts from happening in terms of going out a port. So minus that, yeah, increase bandwidth and know where bursts can happen on the network. If it's voice, video, if it's financial, data, whatever it might be. But yeah, I don't think there's an easy answer there.
Increasing bandwidth comes back to yet the same old thing, right? It's a complexity trade-off. How much configuration and management are you willing to trade off against the cost of increasing your bandwidth, if you can even increase your bandwidth, right? And increasing your bandwidth doesn't necessarily solve all problems, right?
It just moves the goalposts.
Maybe, right? I mean, you can still get into elephant flows on data center fabrics that it doesn't matter how much bandwidth you throw at it, it's going to suck up 100% of that bandwidth no matter what you do, and you've got to be able to do pushback. You've got to be able to move that traffic someplace else, and that's just the way it is. So it always comes down to, in an individual network, I think, thinking through, and this is what I don't think we're very good at being intentional about, is thinking through that type of question. I can go out and fix the problem by adding QoS. I can go out and fix the problem adding bandwidth. Which one of those is actually less expensive? I don't think there's anybody who can answer that question in the networking world today, because we don't know how to quantify either of those costs.
I think that's an individual.
Yeah, it is.
That's going to be a case-by-case basis.
It is.
Sometimes adding bandwidth, like when you're a backbone provider, if you're lucky enough to run your own optical gear, and you can just add waves, or you can move from like 40 gig to 100 gig to in by 100 gig. That's, even with all of that, that's still probably a 6 to 12 month. You got to procure the equipment. You have to do site visits. I mean, it's a very involved process. And so even in those ideal scenarios, I would argue that QoS is something that is a temporary solution while you move towards increasing the pipe.
Right. And segment routing can help, right? In theory, in those places. And that's yet another trade-off, right? Is, do you do QoS in the queuing, or do you do QoS in the control plane? And that's another entire set of...
And that's what I missed out of this whole thing today. Okay, so how do I tie QoS with this stuff? It's too new in my head. I haven't figured that out yet.
Because they obviously offset each other.
Well, if you think about it from like a circuit, like a VPLS-ish type service that you're provisioning, if you're doing an overlay or whatever, you can use PCE to set the reservations based on whatever the customer pays for or whatever. As I've been told 10 minutes ago, because I asked this question, is that you can do these things. That's where the PCE comes into play. So that's an option, and then as we talked about earlier, there's the QoS bits that you can set on the equipment where you have your scavenger and your higher priority stuff as well. But you're trading complexity.
Oh, yeah.
Absolutely.
Yeah. All right, one more topic I think we want to cover, and then we'll call it a day here. Use cases. So Carl pointed out that toward the end, I mean, this whole technology makes a whole lot of sense if you are a content provider, like Comcast or Microsoft. But as you start moving away from that use case, where do you see this fitting in? What do you think? What would you like to see that would make this more of a concrete type of thing where you can kind of see the application making sense for end users that want to adopt this technology? And John just shot his hand right in the air.
Yeah, so for me, this seems light enough that it could be implemented on data center switching platforms, right? And I think a big piece that we're lacking right now is layer 3 isolation on a data center switching platform, right? I mean, I'm not particularly interested in extending VLANs. I'm not particularly interested in extending layer 2 to get that isolation. I'd rather just have an MPLS-like construct that I could bring right down to the VLAN, right? So if I could do that with segment routing, that would be a win there. But I mean, we didn't see an example of that today. I'm assuming it's inherent because of the label stack that it's using. But I mean, it would A, be easier to sell than MPLS because it should be less complex, and B, we could bridge it down into the switching fabric in the data center. But the other piece of that all these technologies, every time we talk about a new kind of I'll just be generic and call it SDN solution, what no one ever talks about is how you connect them together, right? So if it's NSX, it's ACI, it's EVPN, it's whatever, it's, okay, that's cool and all when you're within that fabric, but now I need to connect NSX to ACI, or, you know what I mean? Like, it's the transitional piece of how do you merge those together. And I mean, this should be as simple as MPLS, right, where you could just do it with .1Q tags or something, but it's those pieces, right? How do you tie this into like an entire network? So I'm hoping that segment routing as a whole can bring that one piece further to the server edge, which would mean I don't have to do that transition between them.
Isn't the answer ACI is the underlay and NSX is the overlay? I think there's a presentation on that.
Open question.
Go ahead.
Open question. There's one of the newest and continuous trends right now is SD-WAN in general, right? Multiple vendors out there, kind of overlay solutions, transport independent or carrier independent solutions. Is there an impact though of the need for segment routing on the carrier backbone if you're deploying SD-WAN type solutions? And again, open question. I don't know if anybody has an opinion on it.
I think that was part of, maybe kind of in parallel to that. I think one of the reasons I was saying earlier about like this mid-sized enterprises not having as much of a use case is because they're not running their own carrier stuff. So they would just have SD-WAN vendor XYZ over some carrier, and then in their data center they'll have.
But I mean for that carrier though.
Yeah, for them. Yeah. I see what you're saying. Yeah, this is why I was saying like for the carrier. Yeah, it makes tons of sense to me. But like,
so it depends on what you think, where you think SD-WAN is actually going in the long term, right? If you look at services like what Ariaka Level 3 and some other folks are offering, then segment routing falls right into use SD-WAN for last mile, use segment routing like you would an L3 VPN type service to get the person back to their data center or back into their entry point, wherever it happens to be in their network. So I think that they complement one another. If you're more on the VIP VeloCloud side, then it's kind of a competition, right? But in that it makes it easier perhaps for a transit provider to provision and create the circuits. And one of the biggest complaints everybody has is, I have this massive pet peeve about calling L3 VPNs MPLS services. They're not necessarily MPLS, and that's not the only thing you use MPLS for. Every time I see a headline that says, MPLS is going to die, and you're like, really? Okay. Anyway, so I mean, in that it perhaps helps the level 3s and NTTs and Comcast of the world to provision layer 3 VPN or segmented services faster and easier. Perhaps it competes with the full overlay SD-WAN solutions. So it seems there does seem to be some interaction there, but we'll have to see how it plays out.
It simplifies the backbone architectures as well, is the way that I'm looking at it from a backbone provider perspective, is that as opposed to running this big IBGP mesh with all the L3 complexities in the core, it pushes all that away, and it moves that, the L3 services and the complicated stuff to the edges, and it gives you this fast, flexible core that's much simpler to see. And oh, by the way, it gives you the added benefit of having the ability to look through the tags and know what devices it's touching, rather than create this big complex LSP mesh kind of thing.
Inter-AS VPNs just got way easier.
What's that?
The Inter-AS VPNs just got like infinity easier.
Absolutely. I mean, from with the service provider hat on, this looks like the cat's pajamas.
Yeah, that was a sweet.
Mixed metaphor there.
Good thing, I guess.
And maybe that's the answer. Maybe that this is a technology that makes a whole lot of sense for a specific vertical. And as we move on, I mean, I was telling somebody at lunch today, I can remember when Facebook first mentioned publicly that they were using BGP to the top of rack, and I thought, this is an insane idea. Who would do this? And I think I read my 6th different paper on a smaller enterprise using BGP as a top of rack control system. So eventually, once the use case sorts itself out and as technology changes and moves, using things like this to do mid-enterprise type problem solving suddenly doesn't seem like such a crazy idea.
Well, so that actually touches on something that we talked about a little bit earlier, in that we talk about doing these things in the data center, and a lot of the SDN chatter over the last handful of years has been, I'm going to put these OpenFlow switches in, I'm going to have this controller, and it's going to do all this magic, right? Except for anyone that's ever run OpenFlow at a large scale when it was a production service knows that there's a lot of cobwebs in there. It's hard to do, right? And so this takes that and simplifies it. It distills it down into, like, this is MPLS-ish, right? And so I have the labels, I have the PCE if I need it, but it's more comfortable, at least for me, and I realize that I'm coming from a layer 3 guy. I don't want layer 2 if I don't have to touch it. I can push this down to something that's way more familiar to me.
All right. Well, I think with that, we've pretty much said what we need to say, and I think that this was a great discussion. I think there's some challenges that we've brought up, some lessons that we've learned, and some things like that, and we definitely have a good grounding in what segment routing is. And I like Terry's point that we've essentially created segment routing foundation for anybody out there that wants to learn more about it and do some interesting things with it. So with that, I'm going to sign off for all of the delegates around the table. If you would like to learn more about segment routing, please be sure to check out all the videos that we recorded today. They'll be available at techfieldday.com. They'll also be available on our YouTube channel at youtube.com/techfieldday. And if you'd like to get involved with the Tech Field Day community, you're always more than welcome to head over to techfieldday.com, click on the delegates link, fill out our form that says that you would like to be a delegate like the 7 gentlemen sitting around the table at one of our upcoming events. And if you'd like to know more about the upcoming events we have at Tech Field Day, head over to techfieldday.com and click on the upcoming events link. You can see everything we've got planned out for the rest of 2016, and coming soon we'll have some things for 2017 as well. Thank you very much.